Hello everyone and welcome back to this YouTube channel. Please like, subscribe, comment and even share. Today we are going to look at a singular matrix, and we will concentrate on 2 by 2 matrix. And from our previous videos we had said that a singular matrix is a matrix whose determinant will give a value of 0. So when you determine the determinant of that matrix, the value that you get should always give you a 0. So for a singular matrix, the determinant should always be equal to a 0. So we'll look at an example of two questions here. The first question says, given a matrix A, which is given by 6, 12, A squared, 8, is a singular matrix, determine a matrix A, or simply find the value of A. So we have the matrix 6, 12, A squared, and 8. 6, 12, 8 squared, and 8. And we are told that this is a singular matrix. So if we determine the determinant here, it's supposed to give us a value which is equal to 0. And for the determinant, we said that if you get to multiply the diagonals, the leading diagonal, then subtract the other diagonal, that is how you calculate the determinant. So that we have 6 multiplied by 8, then we subtract the other diagonal, which is A squared, multiplied by 12, and we are saying because this is a singular matrix, then this, all of it should be equal to 0. So that when you have 6 times 8 should give us a 48, then minus 12 times A squared should give us 12A squared, and this one should be equated to 0. So if we subtract 48 from both sides, we'll remain with minus 12 A squared to be equal to minus 48. Should be equal to minus 48. So that we divide everything by 12, that is negative 12. Divide this side by negative 12. The 12 and 12 will cancel. And then A squared, will have A squared to be equal to minus 48 divided by minus 12 will give us a 4. And for us to get the value of A, we get the square root on both sides. So we get the root of A squared, the root of 4, so that now A will be equal to plus or minus 2. Plus or minus 2. And this is the value of A that we have been told to look for. And therefore, our matrix now A, remember they had said that given that matrix A is a singular matrix, determine matrix A. So the matrix A will now look like this. We will have A to be equal to 6, 12, 4, 2, 8. This is the first instance. And the second instant, A can also be equal to, we change the color here, A can also be equal to 6, 12, minus 2, 8. This is because our value for A was being given by either plus or minus 2. And that is done for that question. Let us look at the second example. We'll move this up. So for the second example, the question says solve the equation, and we have k minus 2, 1, 2, k minus 3 is equals to 0. So the moment they have said here is equal to 0, this simply means that our matrix is a singular matrix, and therefore when we evaluate the determinant, it should give us a value which is equal to 0. So we have the matrix, we can rewrite the matrix first, k minus 2, 1. So we have k, let me have the color change. So we have k minus 2, then we have 1, and we also have 2k minus 3. So we have 2k minus 3, and we are told that this one is equal to 0. And they have said you solve the equation. Solving the equation simply means we get the value of k. So this matrix is also a singular matrix. So we evaluate the determinant again and equate it to a 0. So multiply the leading, subtract the other diagonal, so that we have k minus 2. I multiply this with a k minus 3. Then I subtract 2 multiplied by 1. This one should be equated to a 0. And when we evaluate k minus 2 multiplied by k minus 1, so k times k should give us a k squared. Then k times 3 will give us a minus 3k. Then we have 2 minus 2 times k will give us minus 2k. And minus 2 times minus 3 will give us a plus 6. Then minus 2 times 1 will give us a 2, should be equal to 0. We clean this up so that we have k squared. Minus 3 minus 2 will give us a minus 5k. Then plus 6 minus 2 will give us a plus 4 is equal to 0. Now this one, we see it's forming a quadratic equation. So we have a quadratic equation here which has been formed, which we can solve it in any way, either using factorization or using the formula. Either way, it will give us the same answer. So we'll try solving using the two methods. That is, method 1 is by factorization. So by factorization, we say we pick two numbers whose product will give us an A times C, and whose sum will give us a B. Given that a quadratic equation is in the form ax squared plus bx plus c is equals to 0. Now we need two numbers whose product will give us a times c, and also whose sum will give us a b. And comparing this with our question, the product there, the coefficient for a is 1 and for c is 4, so the product should give us a 4, and the sum, the coefficient here for a b is a minus 5. So we need two numbers whose product is 4 and sum is minus 5. And the numbers here will be minus 1 and minus 4. So that when you say minus 1 times minus 4, it will give us a plus 4, and minus 1 plus minus 4 will give us a minus 5. Therefore, we replace them here in our equation so that we have k squared minus k minus 4k, then plus 4 is equal to 0. And when you look at this, when you have minus k minus 4, this one will always give you the value that you have for a minus 5k. So we can proceed here and factor out k. So we have k into k minus 1. For these other two, we have minus 4. We factor out minus 4 so that we have the brackets k minus 1 is equal to 0. Then collect this k and minus 4, so k minus 4 and also k minus 1 is equal to 0. If you open this, it will give you back our quadratic equation which we are working with. And therefore, in this case, we can say k is equal to 4, or also k is equal to 1. So up to that point, we can say we are done solving that equation, but and we have already found the value of k. But let us also use the quadratic formula to solve, so that we can see if we get the same answer. So we want to use the second method, that is the using the formula, and then we see if we get the same answer. So I'm going to rewrite the equation. We have k squared minus 5k plus 4 is equals to 0, and our formula k is equals to minus b plus or minus the root of b squared minus 4ac divided by 2a, whereby our a is equal to 1, the coefficient here of k is 1, our b is minus 5, and our c is 4. So replacing there on our formula, we have k to be equal to minus, and our b is minus 5, so it is minus 5, then plus or minus the root of b squared, which is minus 5 bracket squared, then minus 4 times a, which is 1, times c, which is 4, close the brackets, then divide everything by 2a, which is 2 times 1. So we have k to be equal to, we simplify this, minus will change this to be a plus. So minus times minus is a plus, so we have 5, then plus or minus the root of minus 5 squared is 25, then minus 4 times 1 times 4 is a 16, divide everything by 2. So that now we have k to be equal to 5 plus or minus, then we have 25 minus 16, which is a 9, so we have root of 9 divided by 2, so that we have k to be equal to 5 plus or minus, and now the root of 9 is 3, so plus or minus 3 divided by 2, and we remain with now k to be equal to either 5 plus 3, so 5 plus 3 divided by 2, or 5 minus 3 divided by 2, and k now will be 5 plus 3 is 8, so 8 divided by 2 is 4, so k can be equal to 4, or k can also be 5 minus 3, which is 2, divided by 2, which is 1. Therefore, k can be 4, or can also be 1, which is now the same answer like the one we got using the first method, which is by factorization. Otherwise, that is how we solve equations of singular matrices. And give us feedback, continue subscribing, continue liking our videos, and it gives us the morale to continue preparing and giving you more and more. For those and very many, bye bye.